Hello! In this video, we will be thinking about dividing fractions with meaning. So, what does fraction dividing mean, and how can we make sense of it? For example, what does 2 divided by 2/3 even mean? When would we need to do that computation? Well, let's think about it. Let's say I have 2 feet of rope, or some other string that you can think about, and I'm making bracelets. Maybe you want to make something else, but each bracelet I make needs 2/3 of a foot of rope, or 2/3 feet of rope. How many bracelets can I make? So that could be a question we ask. And in fact, this is a fraction division problem. We can solve this using repeated subtraction. So let's make sense of this using what I call a Frere model. A Frere model takes one concept like fraction division of 2 divided by 2/3, and it ties together multiple representations of it. As you know, this is a theme we've had in our class. How can we think about mathematics in multiple ways so we can be flexible and connect with lots of different ways to think about mathematics? All right, so let's jump into it. As you saw above, we can imagine that we have a rope that is 2 feet long. So I'm going to think of my rope. And of course, my rope looks like a number line, right? And so what I'm thinking about is kind of cutting off little chunks. Every 2/3 of this rope, 2/3 foot of rope, I can make a bracelet. So here's 1 bracelet, 2, and 3. These are called bracelets. All right, so that's the physical context. So I wanted to have that in image as we go into the words. So in words, what's going on? Well, we are thinking about how many times does 2/3 go into 2? In other words, how many bracelets of length 2/3 feet can I make with 2 feet? Okay, so that's in words. We also put a story problem in there. And hopefully you're thinking about your division concept, so your division types. So what type of division is this? Is this repeated subtraction or is this sharing? And if you thought repeated subtraction view of division, you're right. So we're wondering how many 2/3 can I remove from 2? So that will help us make sense of the meaning of 2 divided by 2/3. I could say, how many copies of 2/3 are in 2? So let's go ahead and solve this, finish this off. We'll solve it with a number line. We're almost there. Okay, so 2 feet, 1 feet, 0. Remember, with my number line, this is my whole. And what do I know? Well, each bracelet, it is 2/3 of a foot. So let me demarcate my bracelets. So I need to think about how many thirds are within 2, because then I need to group every 2/3. All right, so here is 1 copy of 2/3, or 1 bracelet. And here's another 1 copy of 2/3, or another bracelet. And finally, here's 1 copy of 2/3, another bracelet. So how many bracelets did I make? 1, 2, 3. So that's my answer. There are 3 2/3 in 2 feet. I can make 3 bracelets. So that's kind of nice. It's a nice whole number. I can make 3 full bracelets. Now I know some of you prefer an area model, so let's think about how I might use an area model to visualize this. So area, remember, means you have square feet. So you're taking up how many square units cover a surface. So here are my 2 square feet. And I know that every 2/3 of a foot I can make a bracelet. And again, this doesn't quite fit with our bracelet idea because usually bracelets are thin like a number line, but maybe it's like a wrap bracelet. It's a fancy thick bracelet. So again, I'm going to count off my 1 bracelet. This is another 1 bracelet. And finally, here's another 1 bracelet. I'm going to shade those in just so we can see these here. So here is the amount for 1 bracelet. Here's another 2nd bracelet. And here's a 3rd bracelet. So here you can see that we can make 3 bracelets. Or in other words, 2 divided by 2/3 equals 3. 2/3 can go into 3. Sorry, 2/3 can go into 2 3 times. All right, so that's our Frere model. We are connecting multiple ways to think about 2 divided by 2/3. But maybe you're saying, well, this seemed like this was nice. It came out to a whole number. I could make 3 whole bracelets. What happens when that doesn't happen? Great question. So let's think about it. So just like before, I'm going to think about my physical rope, but this time the rope is 2 1/3 feet long. And I still want to think, how many bracelets can I make? Okay, so again, we're going to zoom into our words here, and it says, how many copies of 2/3 are in 2 1/3? That is, how many bracelets of size 2/3 feet can I make with 2 1/3 feet of rope? Okay, and again, we are thinking of repeated subtraction. This is a type of division problem. So that tool is really helping us make sense of something that could look a little different. All right, so let's go into it. Let's solve it. And maybe you're thinking to yourself, well, I already know how many are in 2 holes. What does this 1/3 change? And that's a great thing to be thinking of. So 2 1/3. So this time, I still am thinking about how many 2/3 are in here. So I'm going to split everything up into 2/3. So keep in mind, I don't have the other hole here. So there's 2, there's 1, there's 0. But we're still going to count. 1 bracelet, 2 bracelets, 3 bracelets. And then we see here, looks like I can only do something partial there. So we got to figure out how partial is that. Anyways, let's count. Here's 1 copy of 2/3. Here's another 1 copy of 2/3. We're repeatedly taking them out. 1 copy of 2/3. And then our question here is, how much of a copy of 2/3 is it? I know it takes 2 copies of thirds to make 2/3, and I only have 1 of it. So it's half of a copy of 2/3. So altogether, for being really precise, I can make 1, 2, 3 full bracelets and 1/2. So my answer here is I can make 3 1/2 bracelets. Or I have 3 1/2 copies of 2/3 in 2 1/3. And that kind of makes sense because we knew the answer was 3 from above, and we just kind of tacked on an additional third. So I know I can make another half of a bracelet. And I'll leave you to think about what the area model will look like for this problem. I hope this helps you think about fraction division.